Hi, this is Mr. Moss, and in this video, we're going to be looking at how you can estimate quotients using multiples of numbers. This is something that can be a little tricky for students, so I'm going to start off doing a quick review of what quotients are, and then I'm going to show you a strategy that we can use to kind of get back at this skill, kind of reverse. So the first is just reviewing some math vocabulary that we have here. We have dividends, divisors, and quotients. A dividend is the number that you're starting off with. It's your total. Divisor is what you're dividing by, and your quotient is your answer. So for example, I could do 42 divided by 7 equals 6. So my dividend is 42, my divisor is 7, that's what I'm dividing by, and 6 is my answer, the quotient. A good way to remember is your quotient is your answer, and your dividend is your total that you're starting off with. Oftentimes you'll see division problems written this way. For example, I might write the same problem as 42 divided by 7 equals 6. And once again, we have our dividend, our total, our divisor, what we're dividing it by, how many groups we have, and our quotient, our answer. So in this activity, we're looking at how we can estimate quotients, estimate the answers to division problems. And to start off, I want to introduce to you a game called Target Capture. It's a game where we're going to be looking to get this number by doing some multiplication. We know that division and multiplication are very, very closely related to one another. So in this game, we're going to come up with some multiplication problems that are going to get us to an approximate answer. We want to go a little bit higher than our target and a little bit lower than our target in order to capture it. So I'm going to start off by thinking, let's see, 6 times 10 is 60. That's, of course, way too low. 6 times 100, that's getting pretty close, actually. 6 times 100 equals 600. That's really close to 579. I could go a little bit lower and do 6 times 90. Well, let's fix that. 6 times 90. I did 6 times 9. 6 times 90. Well, I know that 6 times 9 is 54, so 6 times 90 has to be 540. So I've captured 579 because I know that it's in between 540 and 600. Let's do another one. I've got 727, and I'm going to capture it using times 5. I know that 5 times 10 is 50. 5 times 100 is 500. Let's try that. Let's do 5 times 100. Well, 5 times 100 is 500. Okay, that's a little bit low. 5 times 200, let's do 5 times 150 as a way of getting something a little bit closer. Let's see what that comes out to be. Well, I know that 5 times 100 is 500. 5 times 50 is going to be 250. So I think that's going to give me an answer of 750 if I break that up and do 5 times 100 and 5 times 50. So I'm going to get between 500 and 700 as my estimate. And sure enough, 727 does fall in between. You're probably wondering, gee, how is this helping with the division? You'll see in just a second. So now we've got 183. Our tool that we're using here is going to be times 3. So let's see. 3 times 5 is 15. So 3 times 50 would be 150. But what about 3 times 60? I know that 3 times 6 is 18. So 3 times 60 has to be 180. That's really close to 183. And if I wanted to go higher, let's try 3 times 70. 3 times 7 is 21, so 3 times 70 has to be 210. So again, we've captured it. Let's do one. Okay, nope, that was the last one of those. So let me explain a little bit of why we're going through this exercise. Remember that our purpose today is to be able to estimate quotients using multiples. Well, we know that multiplication and division are really closely related. In fact, in this example, let me take the problems that I just wrote right over here and rewrite them in another way. I'm just going to change the order, but you'll notice that I'm going to keep all of the answers the same. I'm going to say 600 equals 6 times 100. It's the exact same thing. 6 times 100. I just put the answer on the other side. Let's do the same thing here. 540 equals 6 times 90. And again, it's the same thing, having changed it. The reason why I rewrote that is because I can swap out some of my symbols and turn this into a division problem. I can say 600 divided by 6 equals 100. And I can say 540 divided by 6 equals 90. And so I'm able to recognize the difference between, or the similarities between, multiplication and division here. So let's say somebody came to me and they gave me the division problem of saying 579, I'm using my target number that we used at the beginning, 579 divided by 6. And they said, what is an approximate answer? What's an estimate for 579 divided by 6? Well, I can say, well, let's see, 600 divided by 6, which is pretty close, equals 100. 540, that's quite a bit away, is 540 divided by 6 equals 90. This seems like the closer answer. So if 600 divided by 6 equals 100, then I'm going to say 579 divided by 6 almost equals 100. The symbol for almost equals, I could write it this way. 579 divided by 6 almost equals 100. This symbol right over here tells me that I have an estimate. Let's take a look at how we can do this on the next problem that we had. So we had 727, and we did some multiplication problems to get an estimate. I found 5 times 150 was close to 750. So that's really close to our target of 727. Suppose someone instead said to me, what is 727 divided by 5 close to equaling? What's an estimate for 727 divided by 5? Well, I know that 5 times 150 equals 750. That's a pretty close example. I can always rewrite that, like I said before, as 750 divided by 5 equals 150. If that's the case, I can say that a fair estimate is between, I'm going to rewrite both of my problems here, that my answer is going to probably be between 100 and 150, and that it's probably pretty close to 150. That's how I can get my range. Let's say, again, someone came to me and they asked me, what does 183 divided by 3 approximately equal? Let's get a number that's too high, and let's get a number that's too low, and then let's get an estimate. So if I rewrite these, 180 divided by 3 equals 60. 210 divided by 3 equals 70. Well, I know that 183 is really close to 180 right here. So our answer is going to be between 60 and 70, but it's going to be much closer to 60 right here. So I'm going to say that 183 divided by 3 approximately equals 60. Remember, if you were to write 183 divided by 3 equals 60, that would be wrong. That's saying 183 divided into 3 parts is exactly 60. That's incorrect. We need to make sure that we're using that almost equal sign to represent that this is an approximate answer. You're not always going to have to play the target capture game as a way of figuring out the multiplication problems first. Sometimes you're going to begin by just getting some directions like this, and you'll be given the problems directly. Find 2 numbers the quotient is between, then estimate the quotient. So I've got 213 divided by 7. Well, let me work backwards. 7 times something, 7 times, these are just notes for myself. 7 times something equals something close to around 213. I know that 7 times 10 is 70. 7 times 20 is, 7 times 10 is 70. 7 times 20 is going to be 140. 7 times 30, that's going to be even closer. That 7 times 30 is going to be 210. Ooh, that's going to help me. And 7 times 40, that's going to be 280. Well, I can work backwards from that. I can say then that 210 divided by 7, because we're still using divided by 7. That's how I'm choosing my order. Divided by 7 here. Divided by 7 here. 210 divided by 7 equals 30. And 280 divided by 7 equals 40. So that tells me that my answer has to be, when it says find two numbers the quotient is between, it's going to be between 30 and 40. But then it says estimate the quotient. So if I'm estimating my quotient, I need to come up with the closest answer here. Well, 210 is awfully close to 213, which tells me that my estimate of 30 is the closest quotient. Let's do this next one. Now we've got 258 divided by 4. So again, I'm going to do 4 times something to give me an answer close to 258. I know 4 times 5 is 20, so 4 times 50 is going to be 200, but that's still quite a bit away. Let's try 4 times 60. You know what? You guys are going to find that's an extra line there, and that's okay. We're just not going to use it. 4 times 60 is 240. That's getting a lot closer to 258. 4 times 70 is 280, and now we're over it. Now we're past it. 240 was just a bit below. 280 is a bit above, so we don't even need this line here. That's just helping me to get started. So what I need to do is figure out, okay, let's turn this around. 240 divided by 4 equals 60, and 280 divided by 4 equals 70. So again, how do I go about figuring this out? Well, I know that my answer, my dividend, 258, falls between 240 and 280. So my quotient has to fall between 60 and 70. Which one is it closer to? Again, that's that first part, finding the two numbers between 60 and 70. Now I need to estimate my quotient. Well, when I look here, 258, that's only 18 away from 240. That's quite a bit further than 280. So it's closer to 240, which means my quotient is going to be closer to 60. This has been Mr. Moss working with you on how to estimate quotients using multiples of numbers. And I hope this was a helpful guide for you. I know this is a bit tricky, but hopefully this helped to make it a little bit easier for you. Have a great day.